Hello everyone, let's look over chapter 20, enzymes. Enzymes are protein catalyzed chemical reactions. So presence of the enormous catalytic powers speed up chemical reactions by lowering activation energy and allow reaction to achieve equilibrium more rapidly. High specificity in reaction catalyzed and the substance involved. Regulation of the catalytic activity by the cell, reaction rate, and amount of the formation of any product are controlled by regulating enzyme actions. So you can see absolute specificity. The enzyme act only on one substance. Reactive specificity. Enzyme act on structurally on related substance. Stereochemical specificity. Enzyme has the ability to distinguish between stereoisomers. What is the primary function of the enzymes? That's a catalyst. Earliest enzyme were given names with an IN ending to indicate their protein composition. For example, pepsin, trypsin, chymotrypsin. Also, when you look on enzyme commission EC system, enzymes are groups based on type of reaction catalyzed. Enzyme name specify substrate, function group, act on type of reaction catalyzed, and names and in ASE. So when you see group name, oxidoreductases, the reaction type of reaction catalyzed, oxidation, reduction reactions, transfer of functional groups, transferases, hydrolysis reaction, hydrolysis, addition to double bond, or reverse of that reaction, lyases, isomerization reaction, isomerase, formation of the bond with ATP cleavages, ligases. So for example, hydrolysis of urea. So substrate, that's urea, okay? So function group, RCO double bond NH2, that's amide. So type of reaction, hydrolysis. Then you can generate carbon dioxide and two more of ammonia. So EC name, urea, substrate name, urea, amido, that's function group, and hydrolysis, that's type of the reaction unit at ASE. So that's urea amido hydrolysis. Okay, common names for enzyme. Shorter than enzyme commission names. Formed by adding ASE to the name of a substrate or the combination of the substrate name and type of reaction. For examples, urea amido hydrolysis. So common name is ureases. So substrate urea, common name urea plus ASE. So urease. So alcohol dehydrogenase name is derived from the both substrate name and type of reactions. So substrate alcohol, type of reaction type dehydrogenation, common name alcohol dehydrogenation, and used ASE. Error. So alcohol dehydrogenase. Enzyme Cofactors are non-protein molecules or ions required by enzyme for catalytic activity. Can either be coenzyme or inorganic ions. Coenzymes is organic cofactor is often derived from the vitamins. Apoenzyme is a catalytical inactive protein formed by removal of the cofactor from active enzyme. So apoenzyme regulate cofactor to generate active enzyme. Inorganic ions are metal ions such as magnesium ion, zinc ion, iron 2 ion. So under lactate dehydrogenase, lactate regulate NAD positive to generate pyruvate and NADH and H plus. Okay, let's do problems. What type of reaction does N-methyl transferase catalyze? So that's one transfer of functional group. You can see this one hint. Also, one organic cofactor is called what is name? That's coenzyme. Organic cofactor. If enzyme required zinc ion in order to be an active enzyme, protein portion of the enzyme is called apoenzyme. Okay. Let's look over mechanism of enzyme actions. All enzymes have active site. Active site is the location on enzyme where substrate is bound and catalysis occurs. Binding of substrate may be occurred through hydrophobic attraction, hydrogen bonding, and or ionic bonding. Enzyme substrate ES complex is formed when a substrate and enzyme bond, result in conversion of substrate to product. Chemical transformation of the substrate in the active site is aided by enzyme function groups. After conversions, product is released from active site and enzyme is ready to catalyze again. So enzyme react substrate to generate enzyme substrate complex and release enzyme and product. The enzyme screwase with screws to make screwase complex and release enzyme and glucose and fructose products. There are theories or enzyme mechanism. Number one, Lagging key theory states substrate has a shape. This one substrate has a shape exactly fit the active site. Fit the active site. Limitation imply enzyme conformation are fixed or rigid. So enzyme fixed or rigid. But research proved otherwise. Okay, second, induced fit theory. Modification of the Lagging key theory states conformation of the active site changed to accommodate an incoming substrate. So in induced fit model, flexible enzyme change shape to match substrate. Let's solve problems. What is the substrate for histamine and methyl transferase? Substrate is that's histamine, this one. And then rigid enzyme is associated with the lock and key mechanism of the enzyme actions. Enzyme activity is late at which an enzyme catalyze a reaction. And you see the method of the describing enzyme activity, we can use turnover number. Turnover number is number of substrate molecule act on by one enzyme molecule per minute. Also, we can use enzyme international units. Quantity of the enzyme catalyzed conversion of 1 micromolar of substrate per minute on the specific reaction conditions. There are factors affecting enzyme activity. So increase enzyme concentration will increase concentration of enzyme substrate in complement with the reaction rate theory. So increases concentration of enzyme gives more concentration of enzyme substrate. Rate of the reaction is directly proportional to enzyme concentration, like this one. Substrate concentration. Initial rate of the enzyme catalyzed reaction is responsible to increase in substrate concentration. At certain concentration, the rate level Rn remains constant from here. Maximum rate occurs because enzyme is saturated with substrate, so cannot work faster under imposed conditions. So you can see the shape of a graph, this one. What about temperature? Layer of enzyme catalyzed reactions increase with temperature. Optimal temperature is temperature between 25 degrees Celsius and 40 degrees Celsius. Enzyme activity is highest. Reaction rate is lower above or below this level. Beyond this temperature, enzymes are vulnerable to denaturation. What about pH levels? Enzymes are most effective in narrow pH range and less active at pH values lower or higher than optimal pH. So around 7. So around 7, you can see optimal pH. The rate of the enzyme catalyzed reaction is linearly related to enzyme concentration. Okay, next, enzyme inhibitors. Enzyme inhibitors are substance decrease enzyme activity. Reason to understand enzyme inhibitions characteristic function of many poisons medicines is inhibit one or more enzyme decrease rate of the catalytic reactions. Some substance found in cells inhibit enzyme catalyzed reaction, provide a means for internal regulation of cellular metabolisms. So classify into irreversible inhibitor and reversible inhibitors. Okay, first one, irreversible inhibitors covalently bond with specific function group of the enzyme and render it inactive. So irreversible inhibitors include poisons, toxic metals, so antibiotics, inhibit enzyme essential to the life process of the bacteria, interfere with transfectadase in penicillins. So cyanide ion, extremely toxic and act lethally. Interfere with operation of iron-contained enzyme called syntochrome oxidase. This one, syntochrome oxidase. Form stable complex and does not allow enzyme to function properly. So, styrochrome oxidase react with cyanide ion to generate stable complex. Result in cessations of cellular respiration and cause death in a matter of the minutes. So we need antidote. Antidote must be administered quickly. So sodium thiosulfate convert cyanide ion to thiocyanate ion. This one, SCN negative, does not bind to iron of cytochrome oxidase. Also, heavy metal toxicity caused by ability of the heavy metals such as mercury, lead to render protein part of the enzyme inactive. So metal act by combining with SH group found on many enzymes. So active enzyme react with mercury to generate inactive enzyme. Mercury and lead poisonings can cause permanent neuroneurological damage. Treated, treated by administering chelating agent combined with metal ions and hold them very tightly. For example, EDTA, ethylene, diamine, tetraacetic acid. Chelate all heavy metal except mercury. Calcium salt of EDTAs automatically intravenously. Lead EDTA complex. Lead EDTA complex is soluble in body fluid, is excreted in the urine. Second, reversible inhibitors. Reversibly bind to an enzyme. Can be removed from the enzyme by shifting the established equilibriums. Enzyme react okay, inhibitors to generate enzyme inhibitors. There are two types. Comparable competitive inhibitors. Compete with substrate for binding at active site. Non-competitive inhibitors bind to enzyme in a location other than active site. So first one, competitive inhibitors have molecular structures similar to normal structure substrate of the enzyme. So this is the enzyme substrate, shape of substrate. This one, rubber inhibitors. So on the bottom is similar. The bottom is similar. Action can be reversed by increasing substrate concentration. What about non-competitive inhibitors? Bear no resemblance to enzyme substrate. Interaction between enzyme and inhibitor causes the three-dimensional shape of the enzyme, and each active site of the change. Substrate is improperly bound to active site. Prevent catalytic group of the active site from the participating in reaction catalysis. So substrate concentration does not affect inhibitor action. Regulation of enzyme activity. So, zymogen is inhibitor precursors of enzymes. So, regulation of enzyme activity refers to control of allostatic enzyme. Allostatic enzyme is an enzyme with quaternary structure whose activity is changed by binding modulators. Modulators bind to enzyme activity site and alter its catalytic activity. So may increase or decrease activity. The last one, summary chart of enzyme inhibitors. Inhibitors is composed of irreversible inhibitor and reversible inhibitors. Reversible inhibitor is composed of comparative inhibitor and non-comparative inhibitor. Okay, thank you for watching chapter 20 enzymes.